Something is still out there, and although Oumuamua is now disappearing deeper into the darkness beyond our solar system, the mystery surrounding it hasn't disappeared with it. When Oumuamua was first discovered in 2017, astronomers had only a brief window to observe the strange visitor. It was already moving rapidly away from the Sun, crossing a planetary system that it had never belonged to. But now, the challenge is completely different. As Oumuamua retreats into the outer darkness, reflected sunlight becomes weaker and weaker. Optical telescopes that once tracked its faint glow eventually face a fundamental problem. There simply isn't enough light. And that changes the way we search. Instead of looking for the object itself, scientists can ask a different question. Could anything be coming from it? Oumuamua's journey takes it farther away from the bright inner solar system and toward the vast boundary where the Sun's influence gives way to interstellar space. The heliopause is not a physical wall, but a shifting region where the solar wind encounters the surrounding interstellar medium. Beyond this region, Oumuamua would continue traveling through the galaxy, carrying whatever physical history it acquired in another star system. At these enormous distances, conventional optical tracking becomes increasingly difficult. The object doesn't suddenly vanish, it simply becomes too faint for practical observation. That is where radio astronomy becomes interesting. Radio telescopes don't need to see an object in visible light. They can listen to enormous portions of the sky, searching for electromagnetic emissions buried inside an ocean of natural cosmic noise. But there is a problem. Space is not silent. The universe is filled with radio signals generated by stars, galaxies, pulsars, magnetic fields, plasma interactions, and countless other astrophysical processes. Even the cosmic microwave background provides a faint electromagnetic backdrop left over from the early universe. So if astronomers wanted to determine whether Oumuamua was producing an artificial signal, they would first have to separate a possible transmission from this immense natural background. That means looking for something very specific. A narrow band signal. A repeating pattern. An unusual modulation. Or perhaps a frequency that doesn't behave like the broadband emissions normally produced by natural astronomical objects. This is the essence of the silent signal hunt. The goal isn't to assume that Oumuamua is artificial. Quite the opposite. The scientific approach begins with the assumption that there is a natural explanation, and then asks whether the observations fit it. If a radio anomaly appeared near the predicted position of Oumuamua, astronomers would have to eliminate interference from Earth, satellites, spacecraft, and ordinary astrophysical sources. Only after those possibilities were exhausted would the signal become truly interesting. And even then, a strange signal wouldn't automatically mean aliens. It could come from an interaction involving the object's surface, surrounding plasma, magnetic environment, or some process we don't yet fully understand. But imagine for a moment that the signal survived every test. Imagine it appeared exactly where Oumuamua was expected to be. Imagine it repeated. Imagine its structure couldn't be explained by any known natural mechanism. Then the question would change completely. We would no longer simply be tracking a piece of rock, or ice, or whatever physical object Oumuamua ultimately proves to be. We would be listening. Because the most extraordinary discovery wouldn't necessarily be a photograph of an alien spacecraft. It could be something far more subtle, a pattern hidden inside the noise. A whisper crossing the darkness between stars. And as Oumuamua continues its one-way journey into the interstellar void, humanity faces a strange possibility. Perhaps there is nothing to hear. Perhaps the object is exactly what conventional science expects, a natural visitor from another planetary system, already fading beyond our ability to observe it. But if even a faint, unexplained radio signature were ever confirmed, the implications would be enormous. For the first time, we wouldn't just know that something from another star system passed through ours. We would have to ask whether it was trying to tell us something. And somewhere beyond the heliopause, Oumuamua continues moving through the dark. The telescopes can no longer rely on its reflected light. So now comes the harder question. If the visitor is still talking, are we listening closely enough to hear it? The deeper Oumuamua travels into the darkness, the more difficult the search becomes. At first, astronomers could study the object through reflected sunlight. Its brightness, trajectory, color, and changing light curve provided clues about its shape and behavior. But distance is unforgiving. Every time the object moves farther away, the amount of sunlight reaching it decreases. And the tiny fraction of that light reflected back toward Earth becomes weaker still. Eventually, Oumuamua becomes less like an astronomical target and more like a mathematical prediction. We know where it should be. But seeing it becomes another matter entirely. That is why radio astronomy offers a completely different strategy. Instead of waiting for Oumuamua to become visible, astronomers can monitor the frequencies around its predicted position and search for anything unusual. The key word is anomaly. A genuine artificial transmission would need to stand out from the natural radio environment. Natural sources tend to produce signals with recognizable physical characteristics. Pulsars, for example, generate highly regular pulses. Stars can produce bursts of radio emission. Gas clouds and distant galaxies can generate broad emissions across enormous frequency ranges. Technology can behave differently. Human communication systems often concentrate energy into specific frequencies or structured patterns because concentrating a signal makes it easier to transmit information efficiently. So researchers searching for extraterrestrial technology sometimes look for exactly these kinds of signatures. A narrow signal. A repeating sequence. A mathematically organized pattern. Something that appears too precise to be explained by ordinary astrophysics. But there is another complication. Earth itself is incredibly noisy. Radar systems, satellites, aircraft communications, mobile networks, television transmissions, navigation systems, and countless other technologies constantly fill the radio spectrum. A telescope pointing toward Oumuamua could accidentally detect something created right here on Earth. That means any suspicious signal has to survive an extraordinary process of elimination. Astronomers would need to determine whether the signal changes as the telescope moves. They could observe the same region with multiple instruments. They could compare observations made at different locations. And they could check whether the signal follows the predicted motion of Oumuamua. That last detail would be especially important. If a signal remained fixed relative to Earth, it would probably be local interference. If it came from a distant astronomical source, it would remain associated with a fixed position on the celestial sphere. But if a signal appeared to move exactly as Oumuamua was predicted to move, that would be very different. Still, even that wouldn't prove an artificial origin. The object itself could be producing a natural radio emission. This is where the investigation becomes a battle between extraordinary possibilities and ordinary physics. Scientists would ask, could plasma interactions explain it? Could solar radiation produce the emission? Could the object's composition create an unusual electromagnetic signature? Could dust or gas surrounding the object generate the signal? Could the apparent movement simply be a coincidence? Every natural explanation would have to be tested. And this is why the search for a signal from Oumuamua is so fascinating. The real scientific question isn't is Oumuamua an alien spacecraft? The real question is much more precise. Does everything we observe about this object remain consistent with known natural physics? If the answer is yes, then the mystery becomes one of planetary science and interstellar astronomy. But if an observation repeatedly refuses to fit those models, the investigation becomes much more interesting. And there's something haunting about the timing. Oumuamua was discovered only after it had already entered our solar system. We didn't watch it approach from another star. We didn't see where it came from. We didn't know which planetary system launched it into interstellar space. By the time we noticed it, the visitor was already leaving. Now it is disappearing again. That means humanity may get only one opportunity to study this particular object. We cannot send a spacecraft back in time. We cannot place a telescope beside it.